Let me know once you all see my screen. I'm opening IntelliJ. Okay, so yesterday we learned about the abstract classes and the interfaces, right? Abstract classes and interfaces. Why all these abstract classes and interfaces has come into picture? If you remember, day before yesterday, we were learning about the inheritance, where we passed multiple inheritance. Now let's go back to this multiple inheritance. So far we had seen single level inheritance and multi-level inheritance. So single level inheritance is where there is only one superclass and one subclass. And in the multi-level inheritance, the inheritance is propagated, right? So it will be A to B, B to C, C to D, D to E, and so on like that. Now, what is multiple inheritance? Multiple inheritance is acquiring the properties from one class to from multiple classes to one class, acquiring the properties from multiple classes to one class. That means multiple parent classes and one child class. In a general world, is it possible to have the multiple parents for a child? No, it is not possible. The same thing is not possible here, but there is something called interfaces, right? So interfaces we can achieve this. Let's look at programmatically how we can do this. I'm going to create a new class A B C D F G H I. Hence, let's say I'll put G comma H. This is what the multiple inheritance. Ideally, multiple inheritance should look like this, where we are extending the multiple classes, that is more than one, which is not allowed in Java. Which is not allowed in Java. That's the reason you are seeing this red line here, where it says class cannot extend the multiple classes. Multiple classes, but by using that interfaces we can achieve it. Let's see how we can achieve it. So I'm going to create another class. This time I'm going to create an interface J. Just leave it commented out J, where we have void test. So interfaces cannot have the implemented methods. It will just have the declaration of the methods, right? So it will not have the body. That's the reason we will put the semicolon after the brackets. I'll write another, or I'll name it as test1. I'll write another interface JK. Here I'll have void test. Now let's see how do we implement the multiple inheritance. L hence J comma K. Is it extends? Is it right? It should be implements, right? J comma K. So obviously when you do the implements, you need to implement the methods, both test1 and test2. See, now if you look at it, it is supporting the multiple interfaces, but not the multiple classes like earlier. So this is not supported, where extends G comma H is not supported. but we have can achieve through implements J and K by using the interfaces. Sort of one here is out of test, right? Main method PSVM. So test one and test two are static methods or non-static methods, or non-static methods. So how do we call the non-static methods? We need to create the object reference L1 equal to mu L1 dot test1 L1 dot test is what is the multiple inheritance. If I run this program, you should see the output as test1 and test2. Test1 and test2. This is what exactly is the multiple inheritance. Clear? Any doubts in this? Can I move on to the next thing?
Sure, we can move on.
Okay. So now we learnt about the abstract classes, interfaces, and inheritance is completed now. Inheritance we had covered all the three types, that is single level, multi level, and multiple. Right. Now there is one minor point that we need to learn in the interfaces. So we had seen what did we learn about the interfaces. If we want to achieve the 100% abstractness, then we should go for the interfaces. So interfaces cannot have any implemented methods. It cannot have a constructors, blocks, static blocks, non-static blocks, nothing. It's all the unimplemented. But in terms of the variables, what is the possibility here? So interfaces, we can declare the variables in interfaces, but all of them are public, static, and final by default. So what does it mean? Let's look at example. I'm going to create a new interface int I. So this is the variable I. So what is the meaning of this is all the variables are public, static, and final. So whenever you create a variable in an interface, this is the format you need to write. You should initialize the value at the time of declaration only. You should initialize the value at the time of declaration only. The other keywords public, static, final. So these are the three things, three different keywords. So I is a variable is which is public, static, and final. So for all the old students, everybody understands static, but still we have not covered the public and final, which we'll cover it later. But for now, please remember this point. If we are defining any variables in interfaces, this is the format. You should give a data type, you should give a name, and then it should be assigned. Without assignment, it will not work. Let's say, for example, integer, it won't work because it is final. We'll learn about the final later in detail. This won't work here. But in the classes, this will work. You take any class, right? You take any class, yeah, for example here I, the value is not initialized for this variable. What happens? Default values will be taken into consideration in the classes, but in the interfaces it won't survive with the default values. We have to initialize the value. Variables cannot survive with default values in interfaces. All the variables should be initialized at the time of declaration. The time of declaration. This is the meaning of this. The meaning of this statement is these are the 3 points. Clear? Cool. If any questions, please stop me. Otherwise, I will be keep going. So all of you can ask any number of questions. Even the silly question also is fine. But please don't keep it with yourself, right? So unlike earlier, I cannot call each and everybody's name now, right? To ask the questions. So if you have any questions, you please stop me. Let's learn about the new topic that is called as polymorphism. Polymorphism. Let's close all this. Here I am going to create a new package, polymorphism. So first, let me write some notes. What is polymorphism? What is polymorphism? Polymorphism is the ability of an object to take the different forms. Poly means multiple, morphism means forms, right? So it is the ability of a behavior to implement in the different forms. Okay, it is an ability to perform it in the different forms. Java allows us to perform the same action in many different ways. So that's a simple definition. It allows us to perform the same action in different ways. Right. So ability to perform same action in multiple forms plus polymorphism. This is the simple definition. Poly means multiple, morphism means forms. I think this is in some Greek or Dutch language, which that doesn't matter anyways. But actually this is the meaning of this. Poly means multiple and morphism means forms. How many types of polymorphism? There are two types of polymorphism. What is that? One is compile time polymorphism or method overloading. The second one is runtime polymorphism or method overriding. These are the two types. Let's learn little more details about these two types. Real-time polymorphism or method overloading happens within one class only. Within one class only. Writing multiple methods with same name but with different signature is called as compile-time polymorphism or method overloading. Writing multiple methods with the same name but with different signature. Programmatically, we learn about what is this signature very soon. Okay. Next, we have runtime polymorphism or method override. Runtime polymorphism or method overriding happens with superclasses and subclasses. So basically it involves, when we talk about superclass and subclass, what should be the concept that should come in mind? When we talk about the superclasses and subclasses, what should be the concept that should come in mind? It is inheritance. Basically, it involves inheritance. So there is no inheritance without superclass and without subclass, and there is no superclass and there is no subclass without inheritance. So it's all same. Now, what is the implementation? Writing multiple methods with same name and same signature in both superclass and subclass is called as runtime polymorphism or method overriding. Please try to see the difference between the definition of compile time polymorphism and runtime polymorphism. Here it is, within the same class, multiple methods with the same name but with the different signature. But here, within superclass and subclass, but the methods with the same name and same signature. So this is the major and basic difference between the compile time polymorphism and runtime polymorphism. Why we call it as a compile time polymorphism is it happens at the time of compilation. Compile time polymorphism happens at time of compilation only. Similarly, runtime polymorphism happens the time of runtime only. It has everything. The name itself has everything. You don't have to define something fancy here. Compile time polymorphism happens at compile time. Runtime polymorphism happens at runtime. Both of them have the two different names. So compile time polymorphism is also called as a method overloading, and runtime polymorphism is also called as a method overriding. Okay, so this is all the theory part. Now let's look at the programs, how all these points behaves in real time. I'm going to create a new class under package polymorphism, class A void test. A sort of test. Right? Another method type. What did we write here? We had written two methods with the same name. The name of the method is test in both the cases, but the signature is different. What is the signature? So whatever you put it in this brackets is the signature. Whatever you put it in this brackets is the signature. Now the signature is different. That's the exact point that we were learning here, writing multiple methods with the same name but with a different signature. So this is the difference in the signature. What is a signature, right? Signature can include data types of arguments, data types of arguments and return type. It can only be a data types or it can be both data types and arguments. The return type of method. This is a signature, right? So in this example, what is a signature? For the test method, what is a signature? The signature of test method doesn't takes any arguments. So whatever you put it inside this brackets is called as the arguments. Please remember, this is called as the arguments or the parameters. Arguments or parameters. I is argument or parameter. Argument or parameter. What is the return type here? Void is the return type. Void is the return type. So that means it doesn't return anything. Void is return type. So if we have void, it doesn't return anything. Doesn't return anything. Let's write another program. I'm not going to write the main methods, right? So my main intention is to show the method overloading. So main method is not essential to understand this. Main focus is to have the two different methods with the same name with the different signature. That's it. Class B void test. I'm not even going to write body of the methods also. Void test int I, which we had seen earlier. So this part we had already seen, exactly same as previous program. Void test. What are the other data types that we have? Wide, short, long, float, double, char, string, boolean. So these are the various data types that we have, right? Int, byte, short, long, float, double, char, and string. So if I, so basically I can implement the method overloading or the compile time polymorphism with the test method with the single argument in this many number of ways. In this many number of ways, this is all with respect to the single argument. Either you can have all of them, or only two of them, or three of them, or five of them, or only one of them, right? Whenever you see multiple methods with the same name but with a different signature, right? Signature means what? The number of arguments and the type of the arguments. Number of arguments and the type of the arguments. I can write number of arguments also includes as part of the signature, right? So in this class, we have implemented the compile time polymorphism with the single argument, but with all the different data types. Single argument with all the different data types. Any doubts here? Any questions, please? Okay, I'll write a new program, class C void test void test again, this time int I comma int j. Int I. So this is also called as the compile time polymorphism only. Why? Because we have three test methods with the each of them has the different signature. Here this doesn't have any arguments. Here it has a single argument. Here this has the two arguments. We can write a method with any number of arguments likewise. So each and every method is a different method. So when I just copy paste exactly the same thing, this will not work because it's both of them are the same methods. Both of them are same. I can put something like this. Now this method has the three different arguments. It is taking three arguments, right? Similarly, I can write another thing. Let's say, for example, string j. This is valid where it is taking two arguments. If you see at the line number 13 to 15, this method also is taking two arguments, and this method also is taking two arguments, but the types of arguments are different. Here, both of them are int type, but here, one of them is int type, other one is string type. Another example, let's say, for example, I make it as string. both of these two looks very close, looks very much similar, but still the signature is different because the order of the argument is different. So this is also part of the signature, so we can add even that point: number of arguments, order of arguments, arguments, right? So whenever you are doing the overriding, sorry, whenever you are doing the overloading, you need to make sure that there is no other method exactly the same thing, same way, exactly the same number of arguments, same data types and same order. At least in one of the parameter it should be different, at least in one of the aspect, either data type should be different, or the number of arguments should be different, or the order of the arguments should be different. So if you can take care of all those things, any one of them, then we had achieved the method overloading. Overloading, that means within the same class. Now let's go back to the notes and then see the points that we had written. Compile time polymorphism happens at within the one class only. Within one class only. Have we written more than one class here? No, we had written only one class. See, within the class we are implementing this method overloading. So there is no relation with any other classes here. Likewise, I can write any number of methods with any number of arguments, with any type of arguments, and with any order. But the method name should be same always. Then it is called as the method overloading. Clear, guys? This is the main definition of the signature. This is very, very important in this aspect. Signature can include the data types of the arguments, number of arguments, and order of data types, and the return type of the methods. This is the definition of the signature. Any doubts in this? I'll move to the runtime polymorphism or the method overriding. Class B void test out of D hyphen test. So what is runtime polymorphism? How many classes it will involve? Runtime polymorphism can be implemented using the inheritance. Basically, it involves inheritance. There will be one superclass and subclass, right? So we need to create a subclass now. I'm going to create a new class E extends B. Void test s out of E hyphen. You can add this, you will understand about this particular line later. But here the main thing that you need to understand is, even if you don't have this one, right? Class D, I'll put it in a vertical thing. Alright. So here, what is class D? What is class D in terms of inheritance? It is the parent class or super class. What is E? Class E? It is child class or the subclass. So we have the same method, test method, in class D, which have some implementation which gives a body of D hyphen test. With the same name, we have the same method with the same name, same signature. We have it in the class E, that is in the subclass, but the body is different. This is the runtime polymorphism or method overriding. In terms of method overriding, everything should be same. Everything should be same. Even the signature also should be same. That's the main difference. Clear? For example, let's say if I write, I put int I here. Now, did we achieve the method overriding or runtime polymorphism here? Are we achieving the
No,
runtime
sir.
polymorphism here?
No, sir.
Yes or no?
No, no, no.
No, because the signature is different. Signature is different. Please remember, for the runtime polymorphism, you should always look for the superclass and subclass. You need to look for superclass and subclass. Method name should be same and the signature also should be same. Here, signature is different. So, this is not the example of runtime polymorphism, but this is the example of runtime polymorphism. Let's say I'll write another method, void test of int I. Is this the example of the runtime polymorphism? Is this the example of the runtime polymorphism? Yes or no? Here to here, this is the compile time polymorphism. We have both the concepts here. Within class D, we have implemented the compile time polymorphism. We have two methods with the same name with the different signature. But when you compare with its subclass, test method is implemented runtime polymorphism. If you see the first one, where it doesn't have any arguments, right? Empty signature, right? So this has the runtime polymorphism, but the second one, the test one, does it have the runtime polymorphism here with this void test of int I and void test of short I? These two
No,
comes under the runtime polymorphism, yes or no?
no, sir.
No, because the signature is different, right? Signature is different. Here it is data type is int, but here the data type is short. So these two doesn't comes under runtime polymorphism, but the above two comes under runtime polymorphism, and these two comes under compile time polymorphism. These two comes under compile time polymorphism. Clear? I can write all the methods that I had written here. Again, I'll put the exactly the same thing here. So within class D, it's all the compile time polymorphism, different signature. But when we compare with class E, that is a subclass, then we have implemented the runtime polymorphism, because for this test of int I, we have a method here, test of int I. No, see, there are certain symbols also if you look on the left hand side, right? For example, for the first test method, here you see the down arrow. Down arrow means it has a is overridden. If you just hover the mouse here, it will show is overridden in class e. See, if you just click here, it will come here. See, the mouse cursor come here. Similarly, here if you see, we have the up arrow. Up arrow means it will have the super class, right? That means it has the parent. If you click on this up arrow, mouse cursor had come here, right? Now if I click on the down arrow, because it has the child means down level, right? So the mouse cursor comes here. But for the next one, void test of int I, it doesn't have the up arrow or down arrow. Why? Because overriding is not implemented for this. If I implement this overriding for this, then I'll get the up arrow and down arrow for this also. See, immediately it has got the down arrow. So that means this has overridden in class E. Similarly, if you see this method, we have the down arrow. That means it is overridden in class E. See, I just hover it on this down arrow. You will see the message is overridden in class E. This has the up arrow. That means overrides the method D. Clear? Any doubts here? Any questions so far? Cool. I'll write one final program. How do we call them now? Void test. How do I call all these methods? How do I call all these methods?
Creating an object.
Creating an object, because all of them are the non-static method. F1 equal to new f. F1 dot test. F1 dot test of int I. I need to pass some integer value to call the method. F1 dot test of 10 comma 10. F1 dot test of 10 comma low. F1 dot test of low comma 10. F1 dot test of 10 comma 10 comma 10. So if you see here, this first call is matching which one? The method which is at line number 5, which doesn't take any arguments, right? Here I'll just put it I. Here it will be int I comma int j, int I comma int j comma int k, int I comma string j, k comma int j. So if I need to call this method, what are the arguments that I need to pass? I need to pass the first argument as string and second argument as int. So where am I passing that? At what line number I am passing that? Line number 37. See, if you see here, I am calling the test method here. where I am passing the first argument as string and second argument as number 10. So this is matching this method. So this method will be executed when we call line number 37. For line number 34, which one will be called? For line number 34, where I am just passing one number. So which is matching method here? Line number 9, where it is just taking only one integer value. And for line number 35, which method will be called? Where it is taking two int numbers. So which is the matching method here? Line number 13. Going to line number 36, which is taking the first argument as integer and the second argument as string. Which is the matching method? Line number 21. And line number 37 we had already seen, and line number 38 where it is taking three arguments with all the three integer numbers 10, 10, 10. What is the matching method here? Line number 17. So if I run this program, I'll be getting the exact output. See, this doesn't have anything, and this has int I, this is int, this is int and string, this is string and int, and this is int. Clear, guys? Now you understood how to call the different methods where it is overridden or overloaded, right? Overridden or overloaded. This is the most important thing. If you understand this, then only you can understand how to call the methods. So what values you need to pass to call the methods. Any questions so far? I'll upload all the classes to GitHub. We learned multiple inheritance and what? Polymorphism. All these exercises are available on GitHub site. For the new joiners, I still had not given you the access, right? But for the old people, you can go ahead and take these examples and do the practice as much as possible, right? As much as possible.